Hey yo, it's your boy. Ready to talk about some air pollution. Here we go. Hope you're ready for Unit 7 because I am. So, this unit, we're going to talk about air pollution, what it is, how it impacts us, the world around us, the ecosystems, and we're going to answer interesting, complex questions like how does rush hour impact human and global health? So, today we're just going to get into the basics of air pollution. Um, Air pollution is a pretty straightforward concept. It's any sort of gas or liquid or particulate matter that gets released into the air and has an impact either on the health of living organisms or the climate, right? It's important to distinguish those two. Air pollutants can be primary, meaning that they're released directly into the atmosphere from the source, such as car exhaust, or they can be secondary, meaning that they are transformed within the atmosphere through a chemical reaction. Oftentimes, primary pollutants will chemically react in the atmosphere and form something new in the presence of water or sunlight, and that's a secondary pollutant. This tends to occur more in the daytime and in wet conditions, and some examples include ozone, hydrogen peroxide, and smog. So it's important to remember that pollution, air pollution, is a global phenomenon. It's a global system with input from cities, from livestock and agriculture, from transportation, from industry and factories, but also natural sources as well, such as fires, volcanoes, and lightning. So keep that in mind as we keep talking. There are 6 types of main air pollutants regulated in the U.S. by the Clean Air Act and the EPA, and we're going to talk about all of them today. I like to remember them with a simple acronym that I will show you once I get through them. Here we go. Number 1, nitrogen oxides. Number 2, ozone. This is tropospheric ozone only, not ozone found in the stratosphere. Number 3, sulfur dioxides. Number 4, carbon monoxide. Number 5, lead and other toxic metals such as mercury. And number 6, particulate matter. And then an acronym I use is nose clip. If you want to protect yourself from air pollution, you need a nose clip to seal your nose. All right, let's get started. Number 1, not quite yet. The breakdown of these are all regulated by the EPA and Air Quality Index. And you can see in 2014, most of those emissions were the air pollutants were carbon monoxide. A large chunk of them were also nitrogen oxides, sulfur dioxides, something else called volatile organic compounds. I'll talk about more towards the end, but those play a pretty significant role in air pollution as well. But they are not regulated by the EPA. So something else to keep in mind, residence times. Air pollutants will stay in the atmosphere for different lengths of time. If it has a longer residence time, it's going to stay in the air for longer, sometimes on the span of years to decades to centuries. This means it can have a larger impact on a global scale. Think about things like CO2 and methane that contribute towards climate change, a large phenomenon that affects people over many, many courses of years. Whereas something like nitrous oxides and sulfur dioxides, they're only in the air for a few hours to maybe even days, so they impact things like smog, which can come and go over the span of hours to days, much more local impacts with lower residence times. Okay, let's get into them. Number 1, nitrogen oxides. That can include NO, NO2, and even N2O. When you think of nitrogen oxides, I want you to think of one thing, and that is fossil fuel combustion. That is where most of the nitrogen oxides come from in the atmosphere, is fossil fuel combustion. That's coal, that's generating electricity, but it's also transportation. Nitrogen oxide forms when nitrogen gas reacts with oxygen gas at high heat, high temperatures. And this is one of the reasons why they tell you not to idle your car. You might think it's to reduce the amount of gas you're burning and CO2 you're releasing, but it's actually to cool your engine off. If you shut your car off and you stop idling, it will cool the engine off, and it will help slow the rate at which nitrogen oxides form, because the heat from your engine can actually facilitate this chemical reaction. It doesn't just come from a fossil fuel burning, though. It can also come from natural sources like lightning, soil microbes, that denitrifying bacteria that we talked about way back in Unit 1. It's a respiratory irritant. It can lead to edemas. It can lead to emphysema, and decreased flexibility in your lungs, and bacterial infection. So it's not great to breathe, but it has a pretty low residence time, thankfully. And it can also lead to the formation of acid rain and smog, which are both secondary pollutants. Tropospheric ozone. Again, this is ozone at the lowest level of the atmosphere, at the ground level, not in the stratosphere. It's a secondary pollutant, so it forms in the atmosphere. It's not released by anything, and it forms when sunlight and water react with volatile organic compounds, nitrogen oxides, and oxygens. So when all these things combine and react in the atmosphere, ozone is formed. It can damage plant tissues, it can damage actually animal tissues, and it's a respiratory irritant. It can lead to shortness of breath and sore throats, but also over time can lead to more serious illnesses. It's the major component of smog, along with a few other things, and it has a pretty intermediate residence time. So it doesn't stay around for too long, but it does spend a decent amount of time in the atmosphere. It is formed in one of two ways. In the natural process, the sunlight splits an oxygen molecule into two, and then those two free single oxygens pair up with other oxygens to form a triplet. This is totally natural, happens all the time. But it can also form, ozone can also form when nitrogen oxides and volatile organic compounds react in the presence of sunlight. This is not natural and is influenced by humans because nitrogen oxides come from fossil fuel combustion and volatile organic compounds come mostly from chemicals that humans use like nail polish remover. So the good ozone is in the stratosphere that shields us from Earth's ultraviolet rays. Unfortunately, chemicals found in things like fire extinguishers, in the coolant used in your air refrigerators and your air conditioners contain oftentimes things called CFCs, and these can break down ozone and lead to the hole in the ozone layer, which can allow UV light to come through and lead to higher chances of skin cancer. This is not climate change. The hole in the ozone layer is not climate change. Remember that. They're different things. Meanwhile, tropospheric ozone, the bad stuff at ground level, is bad to breathe and it can lead to the development of smog. Remember, the increase of nitrogen oxides from increased burning of fossil fuels and transportation, combined with the increased release of volatile organic compounds from synthetic products, leads to more ground level ozone, which is dangerous to breathe and can lead to the development of hazardous smog. Here's a picture from China. You can see 4 days apart. This side is a smoggy day, and this day is a clear day. Okay. Again, this is like the third or fourth time now. Nitrogen oxides react with volatile organic compounds in the presence of sunlight to form ozone. This is a pretty important reaction that I would be familiar with. Ozone then can contribute to smog formation, which we'll talk about more next week. Tropospheric ozone can also lead to respiratory illnesses like asthma and emphysema. It can damage plant tissues, which is pretty significant for any agriculture or farmers who are growing crops. And it can also serve as a pretty serious greenhouse gas, absorbing infrared radiation and contributing towards greenhouse effect and climate change. Okay. Number 3, sulfur dioxide. I mentioned it can be released from volcanoes, but it's also released from combustion reactions of fossil fuels, mainly diesel fuel. And like I said, it can come from volcanoes. It's a respiratory irritant, much like many of the others. It can lead to bronchitis, emphysema, etc. And it can also lead to the formation of acid rain. We've looked at a map like this before when we talked about acid rain. There's a lot of sulfur dioxide on the East Coast because that's where most of the coal is in Appalachia, and that's where most of the people are driving their cars all the time. There's a lot of cities here, not a lot of cities out here. So more sulfur dioxide means more acid rain. It also has a very short residence time in the atmosphere, thankfully. Number 4 is carbon monoxide. Carbon monoxide is one that you probably heard of. You might have meters for it in your house that monitor the levels. It's an odorless, colorless gas. You can't see it, you can't smell it, you can't hear it. You need a detector to detect it because it can kill you. It's produced when organic matter is combusted, but incompletely, meaning there's not enough oxygen present. So instead of forming CO2, it just forms CO. So at low levels. This is particularly dangerous in areas that are poorly ventilated, small areas like a garage. People who run their cars in the garage oftentimes, or sometimes anyway, will die in their cars because they get asphyxiated. Carbon monoxide has a very long residence time in the atmosphere. And one of the reasons why it's so dangerous to breathe in is because it has a stronger affinity for binding to hemoglobin. Hemoglobin is in the protein in your red blood cells that carry oxygen around your body. But if you're breathing in carbon monoxide, that oxygen atom in the carbon monoxide is going to bind to the hemoglobin better than the oxygen can. It's going to make it difficult for your body to transport oxygen around. So you're basically going to asphyxiate and die. Don't breathe that stuff. Okay, these are potential danger zones for carbon monoxide. Number 5 is lead. Lead is a heavy metal. It's toxic to breathe or ingest. It can lead to damages to your nervous system, your brain, your spinal cord, your nerves, your ability to move. It was in gasoline for many, many years, but it was phased out in 96 thanks to the Clean Air Act. If you go to the gas station, it will say premium unleaded gas. It literally is referring to lead metal. There's no lead in it, so it's unleaded. It's also found in paint in older buildings and the pipes that pump water in many areas, particularly Flint, Michigan, which you may have heard about. And number 6 is particulate matter, small particles like dust, soot, and ash. These are released from the combustion of fossil fuels or biomass. Think when you burn wood, stuff is flying up into the air. That's particulate matter. Diesel tends to be much worse than gasoline as a fact, though. It could be road dust, could be volcanic ash, could be asbestos, could be pollen, could be ash from fires, dust storms, soot, you name it. Here's some dust being blown from the Sahara across the Atlantic over to the United States. Particulate matter is pretty serious because not only is it bad to breathe, but it can block out the sunlight if it's heavy enough, which can impact photosynthesis and agriculture, but thankfully has a pretty short residence time in the atmosphere. Here's a picture of some particulate matter zoomed in and being released from cars on the highway. There are a couple different sizes of particulate matter. Anything larger than about 10 microns or micrometers is going to be caught in your nose by your mucus and your nose hairs, and it'll be filtered out. But anything smaller than 10 micrometers will not be able to be filtered. It will get trapped in your lungs. It can be concerning. But even more concerning, anything smaller than 2.5 microns or 2.5 micrometers, most significant threat to your health. It can get in your lungs, your trachea, and it can stay there for a very long time, and it tends to be toxic as well. Okay, those are the 6 main pollutants regulated by the EPA. Here are some that aren't regulated by the EPA. One I've mentioned a few times is volatile organic compounds. These are chemicals that are made of carbon and hydrogen. They're hydrocarbons. That's what makes them organic. They're also volatile, meaning they evaporate very quickly. Think nail polish removal, like acetone, or ethanol, alcohol, right? It has a very strong smell. It evaporates quickly. Paint thinner, paint remover, glue, markers, all those things have volatile organic compounds in them. They evaporate quickly. They smell strong. Building supplies, cleaning products as well. Believe it or not, plants do release VOCs naturally, although the lion's share comes from human-related activities because the extraction and combustion of fossil fuel releases these VOCs. And remember that VOCs are an important precursor to smog. So if we want to limit smog, we need to limit VOCs. Here are some more examples. You can see all of these chemical formulas for VOCs have carbon and hydrogen in them. And they're all things that smell, right? Lacquers, adhesives, gasoline, resins, paint, printing ink, plastics, some beverages, right? Any chemical in your house that smells strong is probably a VOC. How about carbon dioxide? Is that an air pollutant? If you go back to your initial definition, air pollutant is something that impacts the health of human or of living organisms or the climate. By that definition, carbon dioxide is an air pollutant because it does affect the climate, so and thereby indirectly affects the health of organisms living in that climate. But it does not directly impact their health. It's not dangerous to breathe CO2. So if you're talking about CO2 as an air pollutant, make sure you make that clear. CO2 is not dangerous to breathe, but it does lead to the greenhouse effect and climate change. Okay. Last step, what can we do about air pollution? We can make laws, we can have changes to our behavior and our culture, or we can advance our technology. I'm only going to talk about number 1 today because that really comes all down to the Clean Air Act in 1963, amended in 1970 and 1990, one of the most successful environmental policies in the United States by far. The Clean Air Act does a lot of things. It sets standards for automobiles and factories on what they can emit in terms of air pollutants. It funds research into pollution control. It facilitates lawsuits between people who are impacted by air pollution. It imposes emission limits on factories and companies. It funds nationwide air quality monitoring system, the AQI, that air quality index that you can see on your Apple Maps. One thing to keep in mind is that the Clean Air Act is a federal act. It sets the regulations, but the states have to enforce those regulations. So every state is going to have slightly different approaches to adhering to the Clean Air Act. The Clean Air Act is super duper successful. Like I said, it phased out leaded gasoline in the late 90s. If you look at this graph, you've got air pollutants on the X, and you've got millions of tons emitted on the Y. Dark orange is 1970, light orange is 2014. Look at the change in lead over those 44 years. It decreased by 99%. Huge, huge, huge change. We're also seeing big changes in particulate matter, sulfur dioxide, and volatile organic compounds. So the Clean Air Act has had a huge impact specifically on lead. It's estimated to have saved over 200,000 lives between 1970 and 1990. It reduced acid precipitation as well, which we talked about before, mainly through a process called cap and trade. And cap and trade is an approach to limiting air pollution by saying, hey, as a country, we can only emit X amount of pollutants per year. And we're going to dole out permits to every single company that allow them to emit a certain amount of those pollutants. So that way we stay below that level. If the company goes over their allowed emissions, if they exceed the permits that they have, they're going to either have to face a fine, pay a significant fine, or they can buy permits that other companies aren't using. So if this guy's not emitting as much as he's allowed to, he can sell his permits to a company that is emitting a lot. And that incentivizes companies to invest in technologies that reduce air pollution. So that way they are saving money and saving the environment, but they can also sell those permits to other companies to make more money. It also allows companies more flexibility depending on their needs. Here's another graph looking at air pollution over time, the number of unhealthy days per year. This is 1985, black is 2015. You can see all across the country, the number of unhealthy breathing air days has gone down significantly. But that's in the U.S., and air pollution in other countries still has a long way to go. They need our support. India, China, Mexico, you name it. The smog there is incredible, and it's not entirely their fault. They have an increased reliance on fossil fuels, but so did we once upon a time, and we still do now. It's important to remember it's our air too. That air does not respect the boundaries of a country. It goes across the Pacific. It ends up in the United States. So it's in our best interest to do what we can to reduce air pollution worldwide, because half the urban population breathes air that is at least 2 times unhealthy compared to the WHO standard, the World Health Organization. And residents of North China die about 5 years earlier than residents of South China. So it's a pretty significant difference across the world. So keep that in mind as we continue our discussion. Okay, if you have any questions, write them down, bring them to class, and we'll pick up this discussion next time. Thanks.